Hello, my name is Victor, and I'm just going to go ahead and start. This will be material used as a recording for uh, the for the future. So my name is Victor. I'm a Gold Microsoft Learn Student Ambassador, and I take a lot of interest in high performance computing. Being part of this program has helped me really focus a lot on high performance computing, and I'd like to share with you some of the things that I've been learning in this so far. So I'll just go ahead and share my screen. Okay, that should be coming through. Okay, so my talk is titled How Automating HPC Workflows with .NET Provisioning Azure Batch Compute and Storage. So as an agenda item, I'm going to look at Introduction to High Performance Computing. I'm going to share a little bit discuss about why we would rather use the Azure CLI instead of the Azure Portal for Batch workloads. And I'm going to also have a bit of a demo on the Azure Batch workload using the .NET framework. So a little bit about my HPC journey. I'm just completing a PhD in computational chemistry. And so my work really involves both wet lab and computational chemistry. And so computational chemistry is what really introduced me to high performance computing. I've been an ambassador for about maybe throughout the entire of my PhD time. And so that program really helped me look into high performance computing as an area to go into. And so this is some of the things that I've done. You can see just with the laser pointer there, this is some of the work that I was doing in terms of studying the reactivity of different atomic sites. This is more of a thermodynamic calculation here, looking at Gibbs free energies between different reaction mechanisms and the energy barriers over there. So I've been slowly getting into HPC for my work and also being an ambassador, and that's really helped me want to explore it further. So my HPC journey got me now working in POSI, in this POSI Supercomputing Center here in Perth, Australia. And that's really helped me see like supercomputing in real life. So at POSI, we have a supercomputer called Cetonix. It has about, it's very big machine, about 2,000 CPU, 200, 1592 CPU nodes. I have about 800 GPUs, and that's really, really massive machine. Number 27, the top 500 supercomputing list. So that's a really good machine that has really taught me a lot about computing. There's different types of workloads that are done on a supercomputer. Some are loosely coupled, some are tightly coupled. So I'll just go on a little bit onto that. So a loosely coupled workload is a workload that doesn't need it runs like the different tasks run independently of each other. What that means, you could run this task on, like part of that task could be run on one node of VM, another part of that task could be run on another on another VM, and these two VMs don't need to talk to each other. They can just get the work done. A good example of this is in rendering. So rendering does this quite well as a task. So there's little or no communication needed. Another type of workload that which actually is more of my area, is the tightly coupled workload. So this one requires the two VMs to talk to each other, and that is where they would make use of the protocol called MPI. And so here is where you have a case where the output, for example, on one VM needs to be sent to the other VM, and that would affect the result. And so that is where you would need MPI, which tends to facilitate that. Sorry. So an example of some cases for this is in computational fluid mechanics, fluid dynamics, and in computational chemistry. So these are really big fields that make use of this kind of tightly coupled workflow. And so these are they tend to be more difficult compared to the loosely coupled workload because they require a bit more overhead. And so this is actually what I did in part one of my series. Is I looked at how to set these jobs up via the Azure portal. So what I want to do for this series is actually demonstrate the same, but we're not going to use the portal. We're going to use the Azure CLI. And so why would we need to use a CLI instead of the Azure portal? So we'd be using a programmatic workflow. And the reason why we do that is from scalability. It's okay if you're going to run a one-off job, but if you're going to scale this like over multiple compute, you need to be able to do it programmatically. Doing it manually is just very, very tedious. Cost efficiency as well. As part of your workflow, you could be able to control the resources. You could be able to say, at the end of the job, clear out the resources, clear out the pool, clear the jobs. That way, it will be done. You don't have to remember to do it because it's been automated. Error handling is also quite important because you can be able to do that if it's written as a set of commands. Error handling is much easier. You can have detailed monitoring and logging as compared to doing it via the portal. Now, why would we use the .NET framework? So, which in this particular workflow, we use C#. Now, .NET really is very well integrated with the Azure SDK. And so it's quite well supported in that sense. And also there's because a lot of organizations use Azure. So it's been well adopted as a framework that can be worked in various cases. There's also an aspect of performance and reliability. Now, this is a compiled language. So C# is a compiled language. If you compare to say Python, which is an interpreted language, so C# is more performant. And another aspect of it is that it natively supports asynchronous and concurrent parallelism, which is something really good to have of your language. I'll just check in to see if there's any questions. No, we'll just carry on. So this is why we're not using a CLI. A bit on the Azure Batch workflows. How does it work? Now, the Azure Batch is an orchestrative service, and so this allows you to orchestrate your job in terms of communication between the storage, between the compute is orchestrated by Azure Batch. You don't have to orchestrate that. You just have to set it up accordingly. Moreover, Azure Batch is a free it's a free service, so you don't have to pay for it. And so it's a tool provided to help you orchestrate your workflow. So how it works is if I just pick up the laser pointer here, you have your inputs, for example. So input could be files and applications. Those need to be uploaded to Azure Storage. And so from Azure Storage, you can create pools. Now, pools are compute nodes clustered together. And these nodes would do a certain task. So you can see here, this pool is a pool of compute nodes. And these jobs would be done on those compute nodes, and each of these jobs is a task. So pool creation, task processing, you can then monitor the tasks. Azure Batch provides services to monitor the task, and then output retrieval is once your job is done, you would then generate some results. These would then be stored again on Azure Storage. And so this whole workflow here is being orchestrated by Azure Batch service. And that is what we're really going to see in this particular demo. So I'll just move on to the demo. So we're going to create this Azure Batch workflow using .NET. I've touched a bit on how the program works. I'll just show a schematic of how it looks. You can see here, here's a schematic workflow. So you can see our input container would contain MP4 files. We would then, that will be used by the application package. So this is sitting on the Azure Batch account. You have your ffmpeg application package. With this software will then run, will do these tasks. And these tasks of really converting this MP4 files to GIF files will be done on this particular node, so via this pool. And so that is the workflow, how it will look like for this particular Azure Batch example. We have a bit of a summary here. So before I move on to the summary, I'll just stop this and switch to another presentation, which really is my demo slides. So, F5. Need to get onto presenter view. F5, there we go. And go back to Teams to share the screen. Okay, so this should be coming through. Okay, so these are the demo slides. So the first thing we really need to do, this is going to be run on the Azure CLI. We need to install our variables. So we have the setup to be installing .NET. You need to make sure on the right subscription. So because I'm a student ambassador, I'm using my Visual Studio Enterprise subscription. I'll create a folder called Qt5 Pets, and over here I would set up a new .NET console. Once I do that, I would then declare my environment variables. Remember, as I've shown previously, we need to, this is going to be done via CLI, so we need to have the right variables in our environment. So the resource, I'll just pick up my laser pointer here. We have the resource group, MLS demo. We have our batch URL here, batch name. All this are obtained from the batch service properties, the batch key, and there's an echo to check. I'll show you that later. And then we also need this. So these are the batch properties, and then we have our storage properties. So our storage name and our storage key. This key is going to enable the communication between different services. So that's the first bit. After that, we then need to be able we move on to imports and namespace. Now, I am not sure how many of you are familiar with the C# syntax, but namespaces are important. So if you notice, we're using this particular using keyword, and this really allows us to be able to import specific libraries so that we don't have to access, we can access the classes and methods without typing in the full path. Now, if you're familiar with Python, Python also has a similar syntax in terms of really importing. So these are the aspects that we're going to be importing. In particular, I want to focus on the Azure Batch. You can notice we're importing the Azure Batch library. This provides classes and methods to manage the Azure Batch resources. So the jobs, the tasks, the pools, that is over from there. There's a storage.blob, which is this one here. And this allows our program to interact with the Azure Blob Storage. So input files, output files, this is how we're going to do that. Obviously, there's also system threading that's going to be for the CPU and compute, but these are the two main tasks. So in summary, really, the Azure Batch service provides classes for managing Azure Batch jobs, and the storage.blob provides services for managing blob storage operations. Now, so the constants and the variables that we're going to specify. Now, if you remember, we've actually read some of these we prepared some of these environment variables earlier, so they're going to be read in at this point. One thing to note here is that you can notice there's a constant variables and there are static variables. So some are constant, some are static. It's important to consider why we are naming these, giving them different names. So the constants are critical credentials that are used to connect the services. And why you need to have constants, especially for some variables, you can see like the env batch URI, which is where is that here URL, sorry, is a static. And so that's important because those are variables that don't change. Our static variables like batch account name, this one here, stores values that are shared across all instances of the class. So what static means is that the variables belong to the class and not to many other particular job instance. So that's just a key difference between constants and statics. So you notice what we have not done yet is that there's a pool ID here, or what's been done in the background is that I actually uploaded ffmpeg software, which is an open source video manipulation software. It's uploaded there. I will show you how we do that in a second, but those are the variables that we need to specify. Now, when coming to the main method, so this is our main thread that's going to run, and it's going to retrieve a lot of variables using the get environment variable. What you really want to note here is this particular async setting or call. And so one of the things that we're going to use a lot when it comes to cloud services in this case is using asynchronous programming. So we use asynchronous programming because It allows tasks to fetch environment variables or services without blocking the main thread. So because we're running on cloud, if you're trying to access another service, there could be many other factors that are affecting your operation. There could be file uploads, could be networking, could be latency, could be many other things that could affect would affect your running. And so if we did not run this asynchronously and run it synchronously, so if you're waiting for files to upload, that means your program idles and you don't really do anything. Now think about this if it was a user interface kind of application. So that means you cannot really do any other thing until all the files are uploaded. That's not very performant and that's not very good for a user. So what the asynchronous call allows obtaining the environment variables remotely, like asynchronously. So while those are being obtained, you can carry on with other tasks of the main thread. So this is a feature I want to point out on the main method we've included over there. So moving on to now the Azure Blob Storage setup. So this is how we connect the Azure Blob Storage to the Cloud Storage account and Cloud Blob client. It's important here because if you note, the blob storage is used to store large amounts of unstructured data. So the reason why we're using blob containers here for this particular workflow is one, they reside within Azure. It's a very easy way of managing and accessing input and output for Azure Batch tasks. So all those MP4 files which we need to fetch, we store it in containers on Azure Blob Storage. So that way, our Azure, our pools and can be able to access these inputs very easily because they sit on a container. So that's the blob part. We then need to upload those files to blob storage. That's the commands for uploading. As I mentioned earlier, the reason why we need to upload it, like these files need to be accessible by compute nodes. So uploading them to the blob storage ensures that we can be able to access this as resource files for processing. If you notice here, we also have an asynchronous call, and this is what I was referring to earlier. You can see you have an asynchronous call as an await. So while these files are uploading onto uploading files to container, you can carry on with other tasks on your main thread. So we're uploading files there. Any questions? I'll just go ahead and check if there's any questions from the floor. Okay, nothing yet. So just carry on. So uploading files to blob storage. That we've catch that. So after that, after uploading the files, we need to create a batch client. Now the batch client is an object that interacts with the Azure Batch service, and it handles all the operation of pull creation, job management, and task execution. And the way it can do this is by using batch checking credentials, which authenticate Azure Batch and by passing the account URL, name, and key. So all these properties are associated with the service, but so that's why we need the Azure shared key credentials, which is being called here. And those will be used to create a batch client, which will handle our pull task creation. So that's what these commands are doing here. After that, we go to actually creating our pull and job. So you can see a task here, create batch pull, and you notice again it's being called asynchronously. So while this is happening, you could do other things. So why do we use pulls in this case? So first of all, if we just run through the code quickly. So this particular command here, await create batch pull. Where is that particular command? This command here creates a batch pull, obviously. And so I've described what a pull is. And in this pull, we're specifying that we're going to have 3 nodes. And they're going to be of the machine size standard D2V2. And this is quite a low, we're using low priority machine here. It's cheap, but it's less reliable, but it's quite cheap for our case here. So that's that bit over there. We then proceed to create a job. Do we have that code here? That code is not shown there, but there's some code here which also leads to a job creation. So pull and jobs creation are created over there. So the VM size is really important because you want to make sure you pick both the right VM and the right number of nodes. You can also set these nodes to scaling. I did demonstrate this earlier in the part one of this series where we created via the portal. There was an option to auto scale your nodes, but you need to be careful about that because that will incur resources as well. And both scale and also the machine size are very important in the costing part of things. So something to keep in mind. So after the job and pull is created, we now need to create the task. Remember, the tasks are the jobs which will be done by the nodes. So this is the code we have for the task. So each task here, if you see the for loop, and so where is the actual task? So here, if you look at this particular string, this is the ffmpeg, is the software. So this is the root part of the software, and then we have the input files here. What you're really doing is doing a conversion of the MP4 to GIF files. So that this is the command line that's running the task. So yeah, we are submitting multiple tasks, and that's why we have a for loop. So the for loop is to enable because you're doing more than one task. We're doing it in a parallel fashion. So once the tasks are created, we need to monitor. Remember, we saw earlier that we need to monitor task completion. Monitoring is important because we need to know when the tasks are finished processing successfully or not. So in this particular, Azure Batch service has this task state monitor function, which helps track the state. And that's whether it's completed or failed. So there's a particular setting command, which is not shown here, but it's called when all. And that ensures that we can only proceed to the next step after all the tasks are finished. Remember, if you're running asynchronously, some tasks may finish earlier than others. And what you want to do is before you move on to the next step, you want to make sure that all the tasks are completed. So that's really important. So after that's done, we then have a cleanup part. Remember, it's always good to clean up. Make sure you don't leave resources idling. So it's good practice really to avoid unnecessary costs, delete your jobs, delete your pools. And so this is I put it as optional, but it's really important to have this code to make sure that we clean up after our jobs are done. That is cleaning up of the jobs and pools. We can also clean up blob containers after you're done. Just make sure that you avoid the necessary costs. Remember, this is quite a hot tier storage. And so if you're really not using it, you can just make sure you clear everything. So that really concludes the part of that's a walkthrough of what the code's going to do. I'm just now going to go ahead and show an actual demo on the Azure CLI. And also we can have a look at polls and see how things look. We can see the code in action. So I'll just stop sharing now. See if there's any questions from the chat. No. Okay, carry on. So the next bit we're going to do is I'm going to move to just a second. I need to be in the right screen. Okay. Almost there. Just bear with me. I'll share screen. Okay. That should be coming through. So what I'm sharing now is my screen. So a few things before we actually move on, look into the CLI commands. I just want to show a few things. I'll just make that more visible. So I just want to move this so I can see. Yep, there we go. You can see. Just go to the Azure portal. Now in the Azure portal, you can see this HPC batch is my batch account. So if you look at all the as part of the properties of the batch account, you can see applications, pools, and jobs. Now, if you look at applications, we already have ffmpeg uploaded as an app. This is the app that will be used by the Azure Batch to run the tasks that we want to do. So it's already uploaded and running, set up properly. If we open it further, we can see the version of the ffmpeg is 3.4. So that is set up and ready to go. And the other thing we want to look at, no, don't worry too much about pools, is, okay, you know what? I'll just go back. So I've shown you the HPC batch. The other thing we set up is the storage, right? If we look at our storage, which is this one, now here, there's a few containers. I think storage browser. So you can see you have number of 2 containers and blobs. I just want to be able to see my containers. So we have the ffmpeg container, and we have an output container. This is actually where the files will be written to. We'll come back to this file. So upon success, those GIF files should be written in this particular container, output container. So we'll come back to have a look in a second. So when we start our job, we should be able to see polls created. So I will go and keep an eye on the polls. So go back to home, HPC batch, and so polls. Keep an eye on the polls here. We also want us to keep an eye on the jobs. You can see this is looking at HPC batch jobs. Keep an eye on that. I think those are the main things. And then later, we will look at the output storage. So this is really all the interfaces we need. So let's just scroll through what the files we have. So we have input files. If I just ls into input files, you can see it has MP4 files. These are the video files that we're going to edit. We're going to work on some time. So we're going to convert these into GIFs. What else do we have here? We have the program.cs. If I use Vim to open this is our, sorry, I'll just Vim it again. So this is our code. This is the program. This is the code that I've just shown you, but written in full from start to finish. It's in this file, program.cs. What else do we need to keep an eye on? So the C# project is just a file that the .NET is using to run this particular program. Now, let's just go ahead and run this particular program. So .NET, if you want to run a particular program with .NET, you would do .NET run. Now, bear in mind what I've already done in the background. I've done a couple of things. I've already loaded up our environment variables. I've already installed the packages that .NET needs. I have installed the ffmpeg app, which I've just shown you. So we're really good to go. So when I do .NET run, it should run everything programmatically. So keep an eye on the command line here, and also keep an eye on what will happen in terms of our pools here and our jobs here. So I think we're ready to go. So let's have a look at what happens here. Okay, so that's running. Input and output containers are created. It's now uploading the files. We did that asynchronously, remember? So you're creating a pool, when ffmpeg pool, and you're creating a job. So if we refresh this, we can see we have a pool here, 3 nodes, right? Current VP. So that's what's happening. If we drill into the nodes, into the pool, we can see that's what we have. At the same time, if we refresh the jobs, we have our job. And remember, our job contains our tasks. This is good because you can see the tasks that you're running here. So we have 6 tasks running concurrently. So if we drill down into one task, so it's actually running in the process of running. So we need to give it time, but you can see that the tasks are actually running in the background. We can't see the tasks that are being run yet until it's done. So we'll have to just park that aside for some time. But if we can see that we have all the tasks that are running in the background. And another thing we can see is a heat map with our pool. So you can see different heat maps. And so this is an indicator of each. We have 3 pools. So we have 3 nodes, and each node is doing this particular. So we have 6 jobs and 3 nodes. So obviously we have more jobs than we have nodes. So It may be that each node may do 2 tasks. We don't know, but let's just wait and see what happens. I'm refreshing, so we can see there's no auto scale, 3 spots that we're having there, and that's running. Just checking on our tasks again. It's still running. Still active, not done yet. So we just give that some time. You can see that we're monitoring. So remember I showed you about monitoring. So we are monitoring, waiting for completion or failure. And then the app will time out in 30 minutes. So either our job is complete or we just have timeout. And it's important to have a timeout because in the event that a job is not complete. So let's just give this some time. Check in again. You can see that one node is changing color. Quite likely that's an indicator that the job's finished. So if you look at this, this is important. You can see that some jobs are completed, some jobs are active. So job 4 is complete now, the other tasks, and so probably all tasks are complete now. So that's done. Now let's drill into one particular task, and you can see that the heat map also is reflective of that. Let's drill into one particular task. So what command is it, would it actually run? So we can look at, let's just make this full screen here. If we look at the text, so this is the ffmpeg file that was run. So remember ffmpeg was called. So I want to see, let's actually look for the code that's running. Let's see if we can get that piece of information. I think that's just, there's not much on the standard out. So standard error output, you can see that it obviously, you can definitely see the program was called. Let's see, I'm looking for a particular command that will tell you. No, normally in Bash, if you have nothing, that means your work was done. It worked fine. That looks like it ran well as well. No problems over there. So if the tasks were completed, obviously the real test is making sure that we have files, right? We have GIF files that are generated. So let's just you can see that there was actually GIFs. Output files is over there. So just really going through and seeing what else we have here. Okay. So looks like it ran. Looks like the file here was generated, one.gif. So that was done. Task was success. It was uploaded. So if you look at this code here, GIF is done and it's only uploaded when the task is successful. Then it uploads it to the blob. We can see to use this particular pool, and the exact node is also noted here. So just go back. So it's the same with the other tasks. So if we look at this one, we can see that this did the task 4 for the uploading number 4 there. So it did task 3, as we can. Sorry, that's actually a good point. You can see it from the ID here. It did task 3. Let's see what. Sorry, I'm actually in the wrong spot. This is the task, so that's fine. Let's look at the polls. This is what we need to drill a bit more into. The polls are idle now. I want to see if we can see what job was done by the poll. Yep, so there's the node names. That's okay, no problem. So we know we formed a pool. We know we had a job, and we know we did some tasks as well. Let's just go back to HPC batch. I want to see the job. Let's just take some time to the job. Look sometime. Right, we've been to this screen. So it's all completed. So what we really want to check is, did we have a successful write? So if we refresh this, yes. You can see that we were able to have our gifts written. So remember we had MP4 files. MP4 files here, if you look at this here, we had MP4 files. We've converted those into GIFs, and those GIFs have been saved onto blob storage. And that looks like it's here. We cannot open GIFs. Can you? No, you can't. It would be good to actually see what they look like, but we can't do that at this point. Let's see. I don't think we can do that. Obviously, because of certain security measures, we can't do that. But yeah, these done, and they're there. We can see that they're created just recently, and that shows our code actually worked. So our program obviously ran, and what's good is that we ran this programmatically. And this was really important to do. And we also looked at the monitoring part as well here. Now, remember I mentioned about resource cleanup. So what we included in our code is being able to delete your jobs. So if we look at our jobs here, we can see we have this particular job. Remember, if you leave things as this, it just costs you resources for no reason, especially if your job's done. So you want to be able to have this automatically just clean up the resources, avail them again, and save your costs. So delete your jobs. We would like to go ahead and to delete our jobs. Now, if you look at here, if you refresh this, our jobs are gone. On a similar fashion, we also want to delete our pools. Remember, our pools are compute nodes. If you're not using them, they cost us money. So if you want to delete our pools, we can go ahead and do that as well. And so if we refresh that, this one will probably take some time to go, but you can see that it's actually deleting, which is good. So it's important to clear your resources. Let's just go back through this interface, make sure that everything is deleted. Our pool, right? That was our pool. So let's come here over to pools. So this one obviously takes time to delete. So it doesn't delete quite easily, but you can see that it is deleting. Another thing that you want to do is delete. So if these files are no longer useful to you, once you've downloaded it, you can keep them there storage or as much as you need, or you can download them for particular use case, and after that you can also go ahead and delete these files. That is just typical post workflow hygiene to make sure that your resources are kept well and you're making good use of cloud resources. So that's that. I will now go ahead. I will go back to the slides to conclude. Okay, I'll share my screen to go to conclude the session. Okay, so that's sharing. I will now share the appropriate one. It must be that one. You should now see my screen. I'll now go back to where we left off. So we've just done a demo. I've shown you how the program works. So we've seen this workflow in the flesh. We've seen it happen. MP4 files, loaded ffmpeg installed as an application package, create compute pools, and have tasks that run on these pools, and the output GIF files into an output container on an Azure storage account. We've seen that done. So summary, this is what we've done. And that program just ran very quickly, but it actually combined a lot of services in one. And so this summarizes what we've done: initialize the environment, upload files. We created a compute pool and the job. We then submitted tasks, and then we monitored and cleaned up our file and to be able to preserve resources. So that's really caps the work we've done. I hope this was an insightful session. I will just I'll go back to this. Is there any questions from the floor? If no questions, I'll stop sharing. And mine is to say thank you for attending this session. Hope you learned lots. Remember, this is part 2 of a 3-part series. the next part is we're going to be actually looking at doing the similar thing, but using Python framework, not .NET framework. So that will be another aspect as well. And we'll probably try a tightly coupled workload and not a loosely coupled workload for that particular point. I hope you enjoyed this session. I encourage you, if you're a student, consider being a Microsoft Learn Student Ambassador. This is a very wonderful program. You get to learn quite a lot. You get Azure credits, and so all I've demonstrated is I've run from my MLSA account. So this is good for you to consider if you're considering wanting to upskill, wanting to pick up more tech skills, especially if you're coming from a non-tech domain. I myself am a chemistry background, so tech skills have been really, really useful for me in my particular field in terms of picking up knowledges in that particular area. So this is good. Consider this for your particular program. Reach out to me on my LinkedIn as well. If that is something on my socials, I'll share this after the event. And hopefully we can be in touch. If not, I will see you in my next session. Thank you very much for attending.